Good day, everyone. Welcome back to Digital Ag Global, your go-to podcast for everything ag tech. I'm your co-host, Clyde Graham of Keystone Solutions, and we're going to be moving into an area that's rapidly reshaping how farmers see, measure, and manage their operations, computer vision, and artificial intelligence in precision agriculture. I think some of the most iconic photos ever taken of farming show an individual farmer out in his field. Perhaps he's staring up at gathering storm clouds, or he's looking down at an individual plant to see how healthy it is. And that's for decades, for centuries, really. Agriculture has been driven by human observation, walking fields, scouting for pests and weeds, checking grain at the back of the combine. Today, cameras and artificial intelligence are starting to take on those tasks at a scale and a speed that no human eye can match. Yurii, why don't you introduce yourself?
Sure, Sen. Thank you, Clyde. My name is Yurii Kovalchuk. I'm CEO and co-founder of Qaltivate. And today we're going to talk about computer vision, AI vision, how it impacts today's AgTech and agriculture or agri-food value chain. We'll also talk about some real use cases for this technology, pest and disease control, managing harvest loss, precision spraying, and all the use cases you can apply this technology to. We have a great guest who will help us to kind of dive deep into this topic. But before introducing Craig, I just want to mention to everyone that Digital Ag Global as a platform for AgTech discussion offer partnership opportunities. So if you want to become a part of our network, have access to speaking opportunities, to all the insights, feel free to drop us a line and we'll sort you out. With this said, let's talk about Craig.
Okay, that's great. Thanks, Yurii. Joining us today is Craig Ganssle, founder and CEO of a company called Farmwave, an enterprise that has become one of the leading names in AI-driven vision technology for agriculture. Craig, welcome to the show. I think you're coming to us today from northern Georgia in the United States. Could you tell us a little bit about Farmwave and how you ended up building an AI and computer vision company for farmers?
Sure. Well, Clyde and Yurii, thank you very much for having me. I'm honored to be here today. And the the short answer to that, Clyde, is by accident. We got here a little bit by accident, but my exposure to artificial intelligence goes all the way back to 1995. I was in the military, and we worked with artificial intelligence a little bit back then. Computer systems were slower and more expensive, but since then I've got an over 30-year career in technology, and I had a company that was building large-scale high-density networks over vast areas like college campuses and stadiums, and we were asked to do it over some research farms for a major seed and chemical company. And in doing so, at the same time, I was doing some other work with Google, and I was asked to pilot and try Google Glass. If you remember the glasses, right? That came out, and through a mutual friend here in Georgia that I'm still connected with today, Bruce, he approached me about glass, and we started talking. He's a farm kid from Missouri that kind of went into tech himself, marketing in technology, but also at AGCO. And we got invited to a John Deere Developers Conference with Google Glass in Iowa, and people wanted to, aside from taking a selfie with Google Glass and check it out, someone asked about the ability to take a picture with your voice, which was one of its features. And I asked the question, not coming from an agriculture background, why do you do that? And you had just talked about it a minute ago, Clyde, the ability for farmers to scout fields and use their eyes to visually inspect things. And that was the answer. Well, I would take a picture and send it to my agronomist or the university ag extension to better understand what I'm looking at from a pathogen pest infestation. And immediately it kind of clicked for me using image recognition and vision computing to solve this problem. And so I asked, what if that picture could tell you what you're looking at? And everybody just kind of looked at me like, what are you talking about? And we started having a conversation about vision-based AI in agriculture. And it really kind of went from there. The first app was developed on glass, and then that was kind of a novelty. We moved it to mobile devices, and then it was being used by thousands of growers around the world. But we wanted to solve more problems, so we started looking at specific use cases, specific problems using vision-based AI across agriculture as a whole. So that's kind of how we got here.
Yeah, I mean, it's interesting that I think many of people in our audience have some, early connection to agriculture, but that not all of them. How has it been where you're moving into a field where you're deploying technology, but you're really kind of a newcomer? Does that give you fresh eyes that maybe others don't have?
It does. We've learned a lot over our 10 years of working in this industry. But if you're the first one paving the way, you're the one that gets all the bumps and bruises, right? So we've certainly experienced that as well. But it's been an immense just education along the way, not only of how we can use AI or vision-based AI in agriculture, but how farmers want to work. This is a very different environment than factory floors and controlled environments. And they have many jobs to do throughout the day. They're constantly on the move. They rely on the weather, right? And other industries don't. It's not such a factor. And so they don't have any control over that. So it was a real learning curve on how do we approach this? How do we apply this with this criteria, with how we can add a value with this technology in this environment. And so it was about 6 years of research and development trying to pave this way and figure out these types of pathways to help farmers.
And so in terms of helping farmers, in terms of providing return on investment, because I assume the technology is not inexpensive, where do you see, where have you had the greatest success in solving problems for farmers, adding value, all those things that are so important?
I think this is true even outside of agriculture, but the technology needs to provide an immediate value proposition. If it doesn't, what's the point of adopting it unless you're just an enthusiast and you're curious about the tech? If it's software, or in our case, software and hardware related, you're asking people to make an investment into this. And so what are they getting out of it? They need to get something out of it. And of a lot of the problems that we looked at solving for in agriculture, vision-based, that was wearable, and then handheld, and then sprayers and planters and harvesters, we saw value in multiple places, but we stuck with harvesting because it was an immediate value proposition. You can make a change right here, right now in the field and see that value. So I think whatever problem you're solving for, the adoption of technology has to be that value-driven proposition, without a doubt. Otherwise you talk about your adoption curve, right? And the early beginners, they're going to invest, and they're curious, and they're tech savvy, and they're enthusiasts, and so they will be first. But for that true application and for it to scale, the value proposition has to be there. And I think that's really what's driven us along the way.
You talk about harvest and the topic of sort of food waste and losses in production and then later on storage is a big issue globally. Do most farmers fully understand how much crop they're losing in the harvest process, and how they can really limit that loss?
been a really big topic lately for us. They do and they don't. I think they do historically from how they have been measuring loss. But that method is very analog. You have to stop, get out, throw down a 1x1 square, measure in the dirt, count the kernels, or use drop pans, which still involves stopping and getting out. And you have a lot of people that don't do it. We all know that labor is an issue in agriculture globally, and finding people that will stop the machine and get out and perform this task or know how to do it. It's very analog. It's quite outdated, and it just doesn't get done a lot. The next sort of iteration were strike plate sensors in the combine. And now that doesn't really involve you stopping. But in the beginning, not coming from farming, we asked, what are these? How do they work? What do you look for? Well, it doesn't measure anything off the header. It's only the combine. Sometimes they get clogged up with material other than grain. Sometimes they miss things or don't work. We've heard mixed stories about their accuracy, and that in the cab, it's really just a meter that bounces up and down and tells you you've got high loss or not. So when we started diving into this and what the research has told us, and we've actually recently been writing a paper in conjunction with some professors and research institutes around the world, it's called the ghost acreage. Farmwave, as an example, is measuring loss 300 or more times per acre or per hectare without stopping the machine. The strike plate sensors don't do that. No one will do that hand count. So when you start looking at this new way of measuring, and you can measure so much more, the data has told us that the loss is more than anyone has realized. And loss to a farmer is literally money left behind. And that's why we went after that. So I think that when you have a conversation, you start talking about harvest loss, farmers know right away. They're like, oh yeah, I know what you're talking about. And we would go to a conference, or if we're at an expo and people are like, so what do you guys do? We'd say, we tell you 300 times an acre what you don't want to know. And they're like, you're right, I don't want to know. They know exactly what you're talking about, right? And it's tough, right? Nothing's perfect, including Farmwave. Yeah. We are far from perfect. So how do we keep iterating on this to get better and better and better with a tool for the farmers? And so I think that it's just been like, they have known, but the paradigm is shifting a little bit to what's really lost. And it's more than just the grain.
Yeah. So how much, in your experience, how much of the loss relates to the equipment and, let's say a new combine versus a older combine, how well the setup has been done in the combine, but other factors too, like whether is the grain too damp for proper harvesting or things like that? What are the variables that that a farmer can control using your technology?
Sure. From an equipment perspective, all of these machines, regardless of the manufacturer, are incredible, impressive machines. Some may have more loss than others but they are better on fuel or capacity or whatever. But really, all of them do a really good job. It's conditions, and you just mentioned that, Clyde. It's the conditions that change that you don't necessarily see throughout the day, from the morning to the afternoon into the evening or after weather. It's those changing conditions that are the big impactor. And then is the operator skilled enough to know what changes to make to reduce that loss? And we've had some, 30, 40-year combine operators helping us with the equation, if you will, of wherever loss is, what to do. And there's, on some of these machines, 70, 80 different types of adjustments that you can make to reduce that loss. But it all depends on where it's coming from. And I think it's been very hard for people to know until Farmwave came along. Where is it coming from on the machine? Is it the header? Is it in the sieve rotor area? Is it all the way, at the very back before, it's coming out? Where is it? Where is it happening? So it's, it really depends on the conditions.
Yeah, interesting. I know when I was on the farm, my dad was always getting out and pulling straw, and he had kind of he'd twist it and then he'd say, yeah, it's good to go, or it's too tough. You're talking a whole other level of decision
Yeah.
making, obviously. Yeah.
Sure.
So Yurii, maybe you'd like to talk about how you view this. Obviously, this is the marriage between, equipment and cameras and a lot of technology, but also it has to interface with the AI and provide the real time data. What are the challenges in making all that work from your perspective?
Well, the I guess there are two main challenges that every company face when they are working with AI or computer vision based technology. The first one is actually developing the algorithm itself, prove that it's efficient, it actually can identify and count something based on photo or video. And Craig just mentioned they spent 6 years in R&D just to make this algorithm. And then after you solve this, you come up with a even bigger challenge: how to adopt it to real world scenarios, because probably your data set was not that full. You had 5, 6, 20,000 pictures, but then you start implementing it on your first early adopters, and the conditions are different, and then you end up spending one more iteration to kind of train your algorithm a bit more, etc., etc. So two main challenges: developing the algorithm itself and then actually implementing it and showing the value when you have it on your test farm or with your early adopters. The one thing though to understand, like, computer vision as a technology, it's not a new technology. It's been around for quite some time, but back in the day you spent a lot of time to do a data gathering, to put together all the data models you need, all the data sets you need. Then you did the data annotation, and then you did the data labeling, and usually it was done by hand by engineers themselves, and it spent a lot of time to do it. Right now you can use AI tools for data annotation, for data labeling. You can use a lot of different open source data data sets to speed up the development of algorithm itself. But then when you go to the field, you still have this second big challenge on how it's gonna perform on a real case scenario on the real field. And I think it's a good question to ask, Craig. 6 years in development, then you go with your early adopters. How was the initial feedback? Did technology work? And counting grains, it's a very sophisticated task. It's not like identifying strawberry or a leaf. It's far more complex from a computer vision perspective.
Yeah, for sure. And you're spot on, Yurii, in sort of what that AI process, right, to build this kind of thing. I think the other factor that's a hard pill to swallow for founders of companies like mine or investors is time. It takes a long time to do this in agriculture, because let's take what we've done with harvest. In the United States, and we started here in our backyard in the US in the Midwest, building this out, we had probably a little bit more than a 90-day window of harvest to collect as much data as possible, try everything we could, test cameras, test our power systems, our feedback loop, like the display, everything. When it's over, you have to wait until next year now to do it again.
Yeah.
Right. So it's a long time. And I think it's important at that point in time to really, some might disagree with this, start thinking globally earlier, because you could, in the off season here, go to Brazil where they're doing harvest and do the same thing, or go somewhere else in the world. That takes funding, that takes money to do that, but to truly go where the action is happening. And that's why it took us 6 years, was because we would do something and then be make some changes over the winter, and that would happen really quick. But now it's like, we can't test it for 9 more months. We have to wait until somebody's harvesting here in the US, or have to go somewhere else. And the other piece that you mentioned, Yurii, is there are some great automation tools today for annotating and things like that didn't exist a long time ago.
Yeah.
But for us, this was so new. There is no historical data on imagery for harvest loss. It didn't exist. There was nothing out there. So we had to start from scratch. We had to start from the beginning, annotating, labeling things by hand, building our own data sets, and then using those tools you speak of to try to automate, because there was nothing out there. Nobody was taking pictures of harvest loss. And even beyond FarmWave, no one was taking pictures like we're talking about of crops, we worked with the University of Georgia. They had what's called the CIDS system, the Consortium for Internet Imagery Database. And for 20 years, UGA was actually starting to take pictures of stuff. But go back 20 years ago, or think about the phone that was used. They were little flip phones.
Yeah.
Cameras were not very good. Imagery was not very good. So a lot of it is hard to use in this capacity. So there was a lot of starting from scratch, which took a lot of time as well. So,
Craig, we've talked a lot about harvest, and I know that's an important part of your business. Where do you see the other opportunities to the most fruitful, perhaps, or the best opportunities for employing this kind of technology?
I think for agriculture, it's really all across the board. Obviously, we've seen a lot of things in spraying, See and Spray and technologies like that. Planting, there's people doing things now with imagery and planting, but you said it in the beginning, Clyde, the farmer will go out and stare at the sky and see what the weather is going to be like. They will scout the fields. It is a very visual based industry. And so across the spectrum, from looking at the health of crops, looking at machinery, what the machinery is doing, it's kind of across the board, and even with animals, right? Getting into livestock, a lot of inspection and stuff there. We've been approached, I don't even know how many times, about could we do XYZ with FarmWave, with vision-based, AI? And the answer is typically yes, but we're a very small team. We've got to stay focused on what we're doing. But, we did some things early on with we used Google Glass in a collaborative effort with us and Google and another company in ag to build a system that could identify and estimate the weight of pigs using Google Glass by capturing a picture.
Okay.
So there's just all kinds of ways, because agriculture is such a visual-based industry, to use vision-based AI tools.
Yeah, I mean, there's even facial recognition now being used in livestock production to identify individual animals, which is, I think, pretty exciting.
Absolutely.
So I think, maybe we can get a little techie here and talk a little bit about some of the specific processes that you're using in order to make all this work. So, if you have an imaging device like a camera in the field, what are the specific kinds of cameras you're using? And then how does that start to interface with the AI?
Yeah, so it's important to note that for FarmWave specifically, we don't really manufacture any of our hardware. We are partnered with other companies. We've stayed very focused on the software and the AI. We work with a company called Luxonis, and they make cameras for artificial intelligence, pretty impressive, rugged cameras. I know there's other companies in AgTech that use them as well. I know Sabanto, my good friend Craig Rupp, he uses them on his autonomous tractors. So we're not, we weren't the first for agriculture for them, but very powerful cameras. lots of capabilities, built for artificial intelligence specific. We partnered with Dell Technologies for our basically our compute power, because the most expensive iPad you could find could not handle what we were doing, right? This is a little bit more than just off the shelf. We got with Dell. Here's what we need to make happen. Can we cram all of this into your rugged tablet? And they did. They were able to do it for us.
Can I ask you a question?
Sure.
Craig, a quick question. Why did you decide to go like on edge to do computing directly with a device in a combine, in a harvester? Why didn't you go like cloud-based technology? Because 10 years ago, everyone was like, yeah, let's do cloud native, yada yada.
Yeah, you're still not going to find connectivity in certain parts of the Midwest U.S., in Mato Grosso, Brazil, and Saskatchewan, Canada. You're not going to have it. Starlink has definitely changed a lot of that. One of our partners in Australia, I mean, they're putting Starlink on all the machines. But when they're doing something like that, that connection's being shared. That's not just for FarmWave. That's being shared by a lot of other things, including their smartphones or whatever else, because there is no connectivity out there. And while I think Starlink and what it's doing is fantastic, there is still some latency there. There is still the signal back and forth that can be degraded with cloud cover. And so when you want that value proposition we talked about earlier in that moment, so that the decision can be made right now, that decision needs to be made right there at the edge. That's where it has to be. And early on in our R&D, we were like, there's no connectivity out here. This has to work at the edge. The answers have to happen like in real time. And so that was a lot of the reason for working with somebody like Dell, was because we cannot rely on that connection.
Yeah, and obviously, if you're going to grow your business, and I'm pretty sure you're an ambitious guy, Craig. I mean, there's lots of areas of the world that are going to have a lot less access to connectivity than North and South America, for example.
Yeah.
But also, sorry, I was just saying, but also this AI on edge trend right now is kind of booming, and everyone trying to get back from cloud to devices that can be physically fitted somewhere. And I think that's very good that you've kind of initially thought, okay, if it's a real-time decision making, then the processing should be done in real time, and you will not be able to attend to the latency that usual connectivity provides.
Yeah, and so other than connectivity, what are some of the other limiting factors that are out there with the existing technology? And is there stuff on the horizon that can conquer those issues?
Yeah, for I don't even know how long now, the equipment companies, everything's been the ISO bus, and it is extremely stable, and that's why we have it, right? It's rugged, it's stable, but the data transfer rates are still kilobit rated.
Mm-hmm.
Our phones are transferring data faster than that. And so I think there's changes coming with still having that stability of the ISO bus right, because all that happens at the edge of what's happening there, but other components of data are changing to different newer modules that are multi-gigabit, and just everything that's happening at the edge, especially when you talk about vision. But even if we were put vision aside for a minute, just other autonomy and data transfer, all the data that's being collected, whether it's machines or drones, there's so much now. And then with vision, you add the file sizes of imagery or video. It's the data transfer rates are vast, multi-gigabit, and yeah, it's got to the on the equipment itself, non-cloud dependent. It needs to move a lot faster.
Could you just maybe bring me up to speed on what ISO-bus is? I'm just not that familiar with that term.
It's like the international standard for connectivity, power, and data on machinery specifically, even beyond agriculture machinery, but construction and other machinery. It's very stable, very reliable, but when you look at transferring data over it, it's rather slow.
When you connect a sprayer to a tractor, you usually have this big socket. You plug it in. It's essentially the ISO-bus socket.
Yeah, it's just big plugs and very heavy duty.
Yeah. So what's your relationship with the farm equipment manufacturers? And, at some point, is this equipment going to become standardized with equipment offerings?
We have worked with all of them. You can name any one of them, and we've worked with all of them. Some of it's been early R&D, still working with some today. Farmwave right now is retrofit, works on any make model combine. And that's been pretty popular because interest rates, cost of machinery, et cetera, farmers are like, for the latest tech, give me something I can bolt onto this existing machine that I have. Mm-hmm. But I do believe that the future of Farmwave and this kind of technology is embedded in the machine, where the AI is in the background and the farmer doesn't really necessarily know that they're using it. The autonomy is happening in real time, making those adjustments in real time, like where Farmwave is talking to the machine, which is our goal by 2028, that we are talking to the machine and we're making those adjustments autonomously in real time at the edge, not dependent on the cloud. And it's all happening in the background.
So the settings on, for example, a combine are actually changing based on signals coming from the Farmwave technology. And the operator is he's talking to his mom by phone or watching a video or
could be whatever. Yeah. Watching YouTube or something.
Buying or trading commodity futures or a little glib, but that's happening in a real-time basis, and the operator doesn't. And I guess at some point it may be part of an autonomous package completely, where there's no operator on the vehicle.
Possibly. We've seen some of the OEMs make tractors and combines like that already, cabless, just fully autonomous. And so when you think about the combine harvester, right, all this time, effort, resources goes into growing a safe, sustainable crop. You don't want to just rush through the field and harvest it, go through. And one of our early adopters and partners, Adam Hinkle, he always says, like, it's not about how much you make, it's about how much you keep. And so you don't want to just rush through the field and hope for the best. Go through and maximize your harvest and get as much of that grain as possible. And there are changes that happen because conditions change, that you need to change settings on the combine, concaves, rotors, sieve, speed, real speed, ground speed, all different kinds of things. And for us to be able to interface with the machine and make that happen in real time, I think that's where this kind of AI needs to go.
Wow, that's that is interesting, I gotta say. So where you've talked a bit about the future. I mean, what are some of the things that you see really emerging in the next, let's say, 5 years or so?
I think Yurii touched on it a minute ago. At the edge is starting to become pretty popular right now,
sure.
Especially in industries like agriculture, right? Because we're learning about, we've been all this time learning about the AI and the value, and hey, we're in the middle of nowhere, northern Brazil, harvesting, and there's not a lot of signal out here, or we can't rely solely on Starlink. So how do we make this work? And it's got to work at the edge. I think you're going to see a lot more vision-based AI in agriculture, more than just machinery, drones, but I think handheld scouting tools. But I think autonomy is going to play a big part of that. AI as a whole, outside of even agriculture, there's been this talk for years now of AI is going to take jobs. From who? We can't find people to do some of these jobs. So that's where AI is going to really add value, is in some industries, and agriculture is just one of them, that it's hard to find people to do some of these jobs. So I think that autonomy is going to be a huge value add. And then it's going to create other jobs in other areas about monitoring, managing, training that autonomy. Because, like you said early on, Clyde, all of this comes from human-centric data.
Mm-hmm.
And I think this is all just going to continue to progress.
Yeah. So there's, I think, a substantial part of our audience are in areas of the world where agriculture is less mechanized, and the scale of farming can be smaller. Those things. Are there any? Can you see how this kind of technology could be employed? To prevent, let's say, harvest loss or other factors in areas where the systems are less mechanized. So you maybe have a stationary harvesting system rather than a combine harvester that is self-propelled and things like that.
Yeah, for sure. I mean, even aside from harvest loss itself, grain quality, there's some of that technology on the machine today, looking at grain quality. But even once the grain gets delivered, like we were approached by a major seed company about using essentially our system to look at grain quality and counting at the shaker tables at the facility. And those are stationary, climate controlled, in an environment, right, that's not like the outdoors, but it's still applying this to look and inspect that grain for quality along the way. I think we're still going to probably see this make its way all the way to the grocery store.
Mm-hmm.
Cameras that are inspecting produce on the shelf, and everywhere in between. Quality assurance and inspection. I think we'll see much more from a visual AI state there too.
I mean, the grading is really interesting because that's still a very labor intensive part of the whole system, grading grain, and it's a bit of a bottleneck too, in that trucks have to stop, and then there's the physical inspection of the grain. Whereas if that can be done remotely, that's pretty exciting, and it would be greater certainty for the flour millers and the food processors and things like that, if they had a more precise idea of the quality of the product they're buying and its attributes. Could this technology also be used to advise farmers on the optimal time, like for, let's say, fruits and vegetables, where your window for quality is very narrow, and they could say, yeah, today's the day to go pick that?
Yes, and that is something that we did back in like 2017, 2018 in Mexico at a huge greenhouse facility for tomatoes. It was stationary cameras that were looking at everything in the greenhouse, and based off size, color, giving them a projected window of time to pick to optimize, going in and picking the tomatoes. Absolutely. Early on, when I had said we started with Google Glass, then we moved to handheld devices, and that was really a scouting application. That was most adopted by smallholder growers in other parts of the world that didn't have access to agronomists or university extension agents like we do in other areas of the globe, for that knowledge, for that, hey, I don't have somebody that I can ask per se, take a picture, what am I looking at? And I think that's going to continue to grow as well.
Yeah. Yurii, we haven't heard from you in a sec. You want to throw in your thoughts at this point.
For sure. Now, the Craig is spot on with computer vision for smallholder farmers, and essentially right now every major farm management system trying to introduce two things: AI agents, AI support of some sort, where you can ask what's going on the field. But the second one is computer-based scanning, where you can take your phone, go to a field, take a picture of your crop, and what is that a pest or disease, or what should I do with it, etc. It's already happening, and I think that's one of the ways to move forward with adopting technology for smallholder farmers. If you cannot put a camera on your combine or on your sprayer, you will put it in your hand and it will go to your field. Right now, in a different parts of the world, pretty much everyone has a smartphone. Cameras are good enough to take a high quality picture. So that's your very simple use case for computer vision technology in agriculture for smallholder farmers.
Yeah. Okay. So we're so. Can you talk one thing that personally I'm interested in, and I think we talked a little bit about this in the pre-call, Craig, is, I mean, we've talked a lot about cameras that are really based on, light waves and sensing that kind of energy. What are some of the other things that cameras can do? What are some of the other things that can measure rather than just, images based on light?
Yeah, there are thermal cameras that certainly can be used with livestock, but even in the plant, the crop world, you get into expensive hardware at that point. Though it's a little pricey, but infrared, we are beginning to retrain our models under infrared for better night harvesting. As an example, Farmwave does kind of work at night now, depending on the lights you have in your machine, but it's not as optimal as we want it to be, and so we're working on that. I think we're going to see more of the IR cameras and other things on drones that are going to do more. So there's a multitude of ways in which the physical visual inspection can be done with different types of cameras. The juice has to meet the squeeze, right? Like the cost. You get some of these cameras that can be really expensive now. They may go down in the future, but they are pretty pricey. What is the value proposition we're seeing now? Is it worth purchasing those cameras for some of these problems? Things like that, I think, are questions that will need to be asked. But ultimately, there's not just machinery or personal inspection, but drones and even just the autonomous hardware itself using cameras.
Yeah. So I give you a little anecdote that I grew up in Saskatchewan, and my great uncle was what was called a weed inspector. And he would go around to find farms where the farmers were not taking care of their weeds, and he could write them a ticket, I guess, and they'd have to pick up their socks and control their weeds better. But his guide was called the Weed Book, and it was filled with all these images, hand painted art images of individual weeds, so that when out he could tell if something was wild oats or whatever the other kind of weeds are. So, and I know we haven't talked a lot about pests and things like that, but I mean, it is indicative of how far we have come in terms of being able to understand what's going on in the field in a real-time basis, compared to where things were probably more than 100 years ago. So,
yeah, I have a quick story on that. So, agriculture is, in a lot of ways and in a lot of geographies, it's handed down from one generation to the next in the family. So for those families, it kind of becomes part of the legacy.
mm-hmm.
And I would say in the last 10 years since we started doing this, and others obviously, that artificial intelligence into agriculture is the first time we are taking human-centric data and digitizing it to live on forever. I had a conversation many years ago with a world-renowned entomologist. This lady was flown all over the world by all the major seed corporations to research and look at all kinds of pest data. And I wanted to have a conversation with her about how she looks at things and what she looks at. And in the very beginning, she was very I don't know about this AI stuff. I don't know if this can replace what I do, et cetera. And I said, it may never fully replace what you do. But I think because you are obviously world renowned, but you're not going to live forever.
Right.
How can we take your legacy, your expertise, and have it live on digitally in this industry to really help people in the future? That might sound like a very morbid answer, but it's just right.
That's not.
We're not going to live forever, right? And she is such a subject matter expert in this that we could name the app after her, and it would be deserving, of course. But how do we get what to live on forever? Because as we talk about succession, not a lot of people want to take over the family farm, or not everybody wants to be a bug doctor, right? Or whatever. How do we get that knowledge to live on? Because once we can digitize it and get it into these autonomous systems, it can live on forever.
Yeah. It goes back to the saying, if I have seen further, it is because I have stood on the shoulders of giants. So anyways, it looks like you're becoming quite a giant in this area, Craig.
Yeah.
So
I don't know.
So it's been a great conversation. Now we're not going to let you escape without providing us with a hot take. And I think you said you might have something a bit controversial. So if anybody's too sensitive, time to dial out now. But I think we're all excited to hear what you have to say.
Yeah. I think the era of precision agriculture as we know it today is broken. And I think that the future really belongs to adaptive technology that ignores the cloud entirely.
Okay.
I think that we've spent decades, and when I say we, I'm not just talking about Farmwave, I'm talking about all kinds of companies, and we spent decades collecting every data point, uploading everything to the cloud to run these massive models and send a prescription or something back to a piece of machinery later.
Yes.
We need it now, not later. We need it now, in that moment. Because the adaptive shift is that there may not be people to do these jobs in the future. And so these machines not only need to have the information to make all these decisions autonomously now, but also talk to each other. Right? So I come from a military background. I'm a big believer in the types of military leadership. Decentralized command is a topic you probably heard, like Jocko Willink and all these others, right?
Yeah.
That's what our fleet needs to be. Decentralized command. If this machine in Mato Grosso, Brazil, just learned something new about the state of, soybean harvest in these conditions, and an update is made to that model, that needs to go out to all machines around the world in the next update globally.
Okay. Well, that's
peer-to-peer.
All right.
And I think that when you think about that, as an entrepreneur, my first question is, who's paying for all of this, right? Like this is development and research and code and things like that. But I also think that this adaptive shift it's going to change how we design future machinery.
For sure.
Right. We talked about that. There were some that there, I believe it was Case years ago, showcased the first like cabless. There was no cab on the tractor. I think it's going to change the design of machinery. I think it's going to change the speed in which things get done. And to just tie it back to something I talked to you about earlier that we're working on with like this ghost acreage, and you talk about harvest loss and it's money on the ground, but how much water and nitrogen was used to grow that crop that you don't get it all out of the field. So then what was the water or the nitrogen that was wasted? And then for the percentage of crop that is sitting there on the ground and rotting, how much CO2 emissions is coming out of that? And so if you could maximize your harvest and get a bigger yield off a smaller plot of land, what would you do with that extra land?
Exactly.
But what if we found a way to free up more of it? What would we do with it?
Well, or prevent marginal land from being taken out of natural things.
Yeah, sure, absolutely.
Right.
Oh, of course. Yeah. You know,
yeah. So I mean, optimizing the farm productive land that we have now is a critically important thing, and any technology that will do that, like Farmwave, is, I think, really important. So thanks a lot for your hot take, Craig.
Yeah.
And maybe we'll do a whole program on adaptive technology in the future and have you back to talk about it.
For sure. Very, very good hot take. I think a lot of people after this will check their cost on AWS or Google Cloud or Azure. We have a question from someone in our audience.
That's my good friend Berhanu from Ethiopia, I believe. Is this autonomous adaptive technology, does it have the potential to be applied in Africa? And what kind of investments would it take for smallholder farmers as well?
Yeah, I think if you're asking about Farmwave specifically, then yeah, I mean, absolutely, it can be used in Africa. Oddly enough, we just had an inquiry from somebody in Africa about a potential dealership with our technology. It can be used anywhere, any make, model, combine, anywhere in the world. Minimum investment would honestly really just be like purchasing a system. And we've found multiple business models to work with people in different areas to reduce import taxes and things like that. And we've got a lot of countries that are, we apply for tax exemption grants because it's agriculture based, and no one else has this, and they're often approved to help get this in the hands of farmers. So it's absolutely possible.
Okay, well, thanks a lot, Berhanu, and I'll have to give you a call because we haven't talked in a while. So thanks very much, Craig. Yurii, do you have some closing comments from today's podcast?
No, very, very, very good discussion. Thank you, Craig. Thank you, Clyde, for orchestrating our discussion today. As usual, stay tuned for next episode in May. And thank you for sticking around and listening about innovation in agri-food value chain.
All right. Okay.
Thanks for having me, guys. I appreciate it. This was great.
Yeah, we really enjoyed
Thank
it,
you.
Craig. All right. Well, have a good day, everyone, wherever you are in the digital ag world.
Yeah.